So today we're going to be looking at implicit differentiation. This is slightly different than explicit differentiation in the fact that we may be taking the change of one variable with respect to a different variable. Up until this point, all the differentiation we've done has been explicit, and it has been set up in an equation format where the variables match up. So if we're taking the change in x with respect to x, we have a term that's been canceling out that we're going to see pops up here. So if we look at number 1, this is going to be, we're taking this expression which has the variable y, but we're taking it with respect to x. So what we're going to try and do is find what is the change in y as we look at a change in x. And the rules are almost the same. This is a standard power rule, so I'm going to say exponent times coefficient, which is going to be 6y, subtract 1 from the variable, squared. But here's where the new thing is going to come up. We're taking the change in y, so dy, with respect to the change in x. And so we have a new term that pops up, which is going to be 6y squared times dy dx. So that's the change in y with respect to the change in x. There's our differentiation aspect. If we look at number 3, I have a term with an x and a y. So what I'm going to do is I'm going to break this up into a polynomial form. I'm going to take the derivative of one part and then separately take the derivative of the second part. So here I'm going to take power times coefficient, which is going to be 1, subtract 1, which is going to be x to the 0th. If you wanted to write this down, you could, but I know that's going to eventually cancel itself out. And then I have the change in x with respect to x. This is what we've seen up to this point, which is why we don't tend to write this, because dx over dx is also going to cancel itself out. When we have the other variable, because the variables don't agree, I'm going to follow the standard power rule. So negative 4 times 3 is negative 12. Take away 1 from the power, dy over dx. This does not cancel out. So what we end up with is 1 minus 12y squared dy dx. If we move on to the next example, what we'll get something that looks like this, where I have two terms multiplied together. All we really need to do in this case is we have a standard power rule. If I say u is 3x squared, that means my derivative of u is going to be 6x dx, not dx dy, dx dx, the change with respect to x, which is eventually going to cancel itself out. If I make my v the other part of the expression, so y cubed, the change or the derivative of v is going to be 3y squared dy dx. We're going to see that part of it is going to show up here in a minute. So let's see, we have uv prime plus vu prime. So I have 3x squared times the derivative, which is going to be 3y squared dy dx plus y cubed times 6x canceled out. And so at this point, we just go ahead and we simplify what we can, how we can. This is 9x squared y squared dy dx plus 6y cubed. Actually, I should put that 6xy cubed. If we do it alphanumeric. Boom. So following standard rules, nothing changes about how we take the derivative. The only thing we need to pay attention to is, do the variables agree? If the only variable is x and I'm taking change with respect to x, I just find the derivative. No harm, no foul, no worries. If I'm taking the derivative of some other variable that doesn't agree with the variable we're taking the derivative of, I just go ahead and I take the derivative as normal, but I include the notation that says, hey, I took the change in y with respect to some other variable that is not y. So having seen that, why don't you take a pause and go ahead and try this equation. Okay, so now that you've taken a shot at it, let's see how you did. So for the first part, I have 6x to the fourth. The variables agree, so I'm going to say this is 24x cubed. I don't actually need to put the dx over dx, but I'm going to go ahead and put it today. I've got the dx over dx. The second term is going to do the same thing. Variable times power, which is going to be 1 dx dx. The only thing right here that I'm going to have to do is I'm going to come off to the side and I'm going to say, okay, if u is 4x squared, that means u prime is going to be 8x dx dx. My v is going to be y squared, which means my v prime, that looked like a u, v prime is going to be 2y dy dx. So I'm going to go ahead and add this in. So this is going to be, we said this is u v prime plus v u prime. And we're going to go ahead and put that in parentheses. For right now, it's not going to make too much of a difference because we're adding these things. The addition signs are going to cancel themselves out. But let's continue forward. So 24x cubed, we know that's going to cancel out, equals 1, because those both are going to cancel out. And let's go ahead and plug this in. So u is going to be 4x squared. V prime is going to be 2y dy over dx plus v, which is y squared. U prime, which is 8x. Those cancel out, so I'm actually not even going to put that. Then at this point, we combine what we can, how we can. So 24x cubed equals 1. Alphanumeric, that's going to be 8x squared y dy over dx plus 8xy squared. So we see the derivative doesn't really change in how we take it. We just have to keep in mind, do the variables agree? And if they don't, we include the notation of when they disagree. So that is going to lead us to the second part of this. Now that we know how to take the derivative, what we want to do is we want to say, hey, let's isolate what is the change in y with respect to x. It's going to be a more useful form of using this mechanic. So the same process is going to apply. We're going to take the derivative of this equation with respect to x. So anytime I only have an x in the term, I don't need to worry about having the disagreeing variables here. So I have 6x squared dx dx. This is going to be 4y dy dx. And then the constant is just going to cancel itself out. So this is what I get. I notice that the dx cancels out. And really all I'm trying to do is isolate this dy over dx. So let's clean up the expression and see what we need to divide by. Let me get that. I'm going to need to divide both sides by 4y to isolate that, which is going to be a 6x squared divided by 4y is dy over dx, which is going to fully reduce. That's going to be, what, 3/2 x squared over y. Cool. And we have the derivative of y with respect to x. We've isolated that term. Let's do one more. Now, because we're finding the change in y with respect to x, we're going to take the whole equation with respect to x, and we're just going to isolate the change in y. So this is going to be 10y dy over dx, 6x squared dx over dx, minus 5 dy over dx. Okay. So what I've got here is I've got 2 dy dx's. Not too bad. I'm just going to have to put them both on the same side before I try and isolate it. So I know these are going to cancel out. I'm going to add that over here. So I have 10y dy over dx plus 5 dy over dx equals 6x squared. Now that I have both my dy dx's over here, I'm going to factor that out of the equation. So dy over dx, 10y plus 5 equals 6x squared. Then to get rid of that, I just go ahead and divide it. So I get dy over dx is equal to 6x squared over 10y plus 5. And now this mechanic is going to be useful for our related rates, which is an upcoming section. The idea is we're going to set up some sort of static equation and take the derivative, and we're going to find one of these values so that we can plug in other known quantities. But we have 2 more questions. What I want you to do is I want you to pause the video, and I want you to give your best shot at this right here. So go ahead and try 13 and 15, pause the video, unpause it when you're done, and see how well you did. Okay? Now that you've had the chance to try it out, let's go ahead and take a look and see how you did. So I have the single aspect right here, which is going to be 15x squared dx. Ooh, I have a subroutine. So my u is going to be negative 3x, which means u prime is going to be negative 3. V is going to be, I'm going to put the dx's in there as well. It's going to be y, so v prime is going to be 1 dy over dx. So if I have my v u prime plus u v prime, that's going to give me, let's see, y times negative 3 plus negative 3x times 1 dy over dx. So negative 3y minus 3x dy dx. That's going to go in for the derivative of this term right here. And then I know the derivative of 2 can just go ahead and cancel itself out. I look through my expression right here. I only have 1 dy dx. I can also get rid of that because that will fully reduce. So my first step is move that 3y over. The last step is to divide by that negative 3x. Now I could separate this into 2 terms and have the x's cancel out over here and still have a second rational aspect, or rational aspect over here. But I'm going to go ahead and leave the x on the bottom, but I am going to reduce it by 3. Which means that I will get, I'm actually going to divide these both by negative 3. So that way the negative moves up to the top. So that would be a negative 5x squared minus y. All over x is dy over dx. Boom. Found the change in y with respect to x. So how will you do right there? The next one, ooh, it looks like we have a double chain right here. So the first thing, what we're going to have to do, first part's not a big deal. That's going to be a 6x squared dx over dx. Now this, I'm going to have to use a little bit of the chain rule. So I'm going to let u be 3xy plus 1, which means u prime, I'm going to have to go and do a second. We're going to say this is going to be my alpha. So I'm going to come down here and do that. But that would mean that my function with a u is going to be u squared. So my function prime of u is going to be 2u. Okay. So then I'm going to come and I'm going to say, okay, here we go. So if I have, let's see, so if I have 3xy plus 1, what I know is that I'm going to say u is going to be 3x, which means v is going to be y. So u prime is going to be 3 dx over dx. v prime is going to be dy over dx, because it's just going to be a 1. Cancels out, so vu prime plus uv prime. It's going to be y times 3 plus 3x times dy over dx. So there's my a. Pop that back up here. 3y plus 3x dy over dx. Okay. So if I fill out this, that's going to be f prime of u times u prime. So my f prime of u is going to be 2 is 3xy plus 1 times u prime. So 3y plus 3x dy over dx. Boom. And that is the derivative of this side right here. Looks a little gnarly, but I think we can untangle it pretty well. So, yeah, I guess I'll just go ahead and write it right here. So 2, 3xy plus 1, 3y plus 3x dy over dx. Perfect. And so this, albeit was a little tricky to get this double substitution in there, this is going to be very straightforward. I'm going to cancel out these two terms by dividing it over here. So I'll have a 6x squared divided by, let's see, if that'd be a 6xy plus 2. If I went ahead and distributed that 2 and then divided both of those away, is going to equal 3y plus 3x dy over dx. So do you see how we divided those both over here? Now I'm left with just what was in this expression right there, which allows us to, let's see, if I divide everything by 2, that's a 3x squared over 3xy plus 1. And I have subtracted the 3y, and I'm left with a 3x dy over dx. I'm going to go ahead and divide everything by a 3x. So if I divide this by 3x, I'm going to change flip. So 3x squared I've isolated it. Now I just got to clean up a little bit. The 3's cancel out, and one of the x's cancel out. So I have x over 3xy plus 1. The 3's cancel out, minus y divided by x. Now I could clean this up into a single fraction, but at this point I think we've got it isolated. That's as far as I'd be willing to go to simplify it. And there we go, implicit differentiation.